So now we're ready to take a look at the math. And the math, we're going to do it first with interaction, and then because as you saw with this data, there is no significant interaction, we're going to rerun it without the interaction. So first interaction, then without. Degrees of freedom, pretty easy. For the factor 1, it's just the number of factor levels minus 1 for factor 1. So the number of levels for factor 1 minus 1. Factor 2 is the number of factor levels for factor 2 minus 1. The interaction is your factor 1 degrees of freedom times your factor 2 degrees of freedom. Then error is going to be your total number of measurements minus the number of factor levels for 1 times number of factor levels for 2. And then total is just going to be your total count minus 1. So sum of squares, this is where it gets a little bit more complicated. So here the different factors are the same, just switching out the factor groupings. So the sum of squares for each factor is the number of factor levels for that factor times the total number of measurements over both factor levels multiplied together times the sum of the squared deviation of each group mean minus the grand mean. So each group mean is the mean of each level. And then SS interaction is going to be our total minus error minus factor 1 minus factor 2. So we're going to have to take a look down here at our SS error. And SS error is we're going to look at each individual group for each factor. So, you're going to say, okay, factor 1, group 1, factor 2, group 1, factor 1, group 1, factor 2, group 2, and then you're going to be comparing each of those individual values in those groups with their group mean. Again, this will make more sense when we get to Excel and we're actually looking at the workbook at all of this math. Okay, so then our sum of squares total, this is awesome. It's just the sum squared deviation of each individual measurement from the grand mean. Pretty easy to calculate. Mean squares, quite a bit easier. It's just the sum of the squares for each source of variation over its degrees of freedom. So SS of each factor over the DF of the factor, SS interaction over DF interaction, and so on. Now in the F statistics, we only do it for factor 1, 2, and interaction. And so this is really where the difference comes from having an interaction term and not. So the F value for factor 1 is going to be the mean squares of factor 1 over the mean squares of the interaction. Factor 2 is going to be the mean squares of factor 2 over the mean squares of the interaction. And then the F statistic for the interaction is going to be the mean squares of the interaction over the mean squares of the error. Now moving on to the p-values, we in Excel can use f.dis.rt to get the right-tailed probability of the F distribution for the F value. So F of factor 1, and then our numerator degrees of freedom is our degrees of freedom for factor 1 because that was on the numerator. And then our degrees of freedom for our interaction is our denominator. And the same for factor 2. Except we use the F for factor 2, the DF for factor 2, and still the DF for the interaction. Interaction's a little bit different because now our numerator degrees of freedom for interaction is for the interaction, and then our denominator is the degrees of freedom for our error. Again, the F value is for the interaction term. But so here we have the summary of this table, all of the math here, and like I said, very shortly we are going to go in Excel and actually calculate this. I just wanted to walk you through this so that you could see all of the equations for yourself.